Hello together, my name is Toby and I'm a member of Reutlingen University's RoboCup team. Since COVID-19 has arrived on this planet, nothing really is the same. This applies for our lectures as well as for Christmas markets and sadly also for RoboCup. To match the overall situation, this video is recorded from home for the safety of everyone. Let's take out the garbage.
Pizza.
Ooh, it's a film grip.
It's too thin, is it?
No, that counts twice.
No, that's good. Yeah, on. Oh, yeah, on camera.
First points for the Lions.
The first time.
This video was recorded in 2019 during the RoboCup World Cup in Sydney. Although our robot dropped the garbage once, he managed to recover from the failure and managed the task successfully. The next task is carry my luggage from the same competition. Come on. Yeah. You did it. Awesome.
Not yet.
So you want to follow me, huh? I can push it back.
Yeah, you have to push it back.
Okay, 1, 2, 3.
Give me back my nose!
I can follow you. Please stand about 1.5 meters in front of the robot. Are you ready? Then say yes.
Yes.
I will follow you now. Please start walking. Nice answer. Please answer with yes or no, and speak loud and clearly. Follow you. Please stand about 1.5 meters in front of the robot. Are you ready? Then say yes.
Yes.
Okay, I will follow you now. Start walking.
Again, we kinda had some problems. The upside is there is enough things for us to optimize for RoboCup 2022 in Bangkok. In the next clip, you can see the Where Is This challenge.
Hello, my name is Leonie. Please tell me your name.
My name is Carmen.
Hello, Carmen. How can I help you?
Where are the cornflakes?
Please follow the hallway to the next door, on the right side. Then enter the door to the RoboCup room. There will be a shelf on the left side. The cornflakes are placed inside the shelf. Do you want me to guide you to the cornflakes?
Yes.
Do you want me to guide you to the cornflakes?
Yes.
Please follow the hallway to the next door, on the right side. Enter the door to the RoboCup room.
Ja.
There will be a shelf on the left side. The cornflakes are placed inside the shelf.
Now, Michael will tell you something more about our team.
Hi, my name is Michael Denner, a team member of the German RT Lions RoboCup-at-Home team and research staff at the Department of Technique of the Reutlingen University. I would like to take 5 minutes to present our RoboCup-at-Home research poster. In the beginning, there are 5 departments at our RoboCup team. The navigation team is for moving the robot from one place to another. Second, the manipulation workers teach the picking and placing of all kinds of objects. Then there's the perception team that uses cameras, microphones and speakers to interact with the environment. All modules are connected by the people working on the brain. This abbreviation stands for the best Reutlinger artificial intelligence network ever built. Finally, the assembly operators invent new hardware and maintain our robots. Let's start with our research in navigation. For collision and obstacle avoidance, as well as trajectory planning, robots usually generate and use a simple 2D coast map without any semantic information about the detected obstacles. Thus, a robot's path planning will simply adhere to an arbitrary large safety margin around obstacles. A more optimal approach is to adjust this safety distance according to the class of an obstacle. For class prediction, we trained an image processing convolutional neural network. One of the main problems in the development and training of any neural network is the creation of a training dataset. We used methods and free open source software allowing a fast generation of annotated datasets. Our pipeline can be then applied to various objects and environment settings and is extremely easy to use to anyone for synthesizing training data from 3D source data. We created a fully synthetic industrial environment dataset with 10,000 of physically based rendered images and annotations. Subsequently, we trained a CNN with our dataset for coast map safety class prediction. We analyzed different class combinations and showed transfer learning the safety classes end-to-end directly with a small dataset instead of using a class lookup table that improved the quantity and precision of the predictions. We proposed 3 different class groupings on our dataset for our experiments. First, all dataset objects as their individual class. Second, similar objects grouped by type classes. And third, objects directly grouped into safety classes. The manipulation team works on a novelty for picking up objects. We generate volumetric 3D environment models with Octomap. The error in range measurement is usually very high and therefore an updated environment mapping in real time is necessary. Octomap is an integrated framework based on octrees for the representation of 3-dimensional environments. We use this new method not only for navigation but also for gripping tasks. Hence, this also supports the gripping point detection and orientation of the objects. In parallel, the team had also to handle the simulation challenges of picking a virtual object with a home service robot. Many experiments and trials took a lot of time, and finally there have been more and more successes. The perception team worked on synthesizing training images in Blender. The semi-automatic script is able to generate thousands of RGB images in a few hours. The objects are then extracted and combined with an artificial background that corresponds to the simulation arena. In this step, the labels and positions of the objects are also stored. In a second approach, an arena scenery has been built in Unity 3D, including random YCB objects in the shelf, on the table or on the floor. Again, the labels are also generated by Unity. Therefore, no manual annotation had to be done for this year's challenge. The training data then was trained on the darknet YOLO network, and we achieved a high recognition rate. Our brain combines all modules and orchestrates all states of each challenge. The tool we used is called RoboCup, that supports the creation of state machines for robot programs. The specialty of RoboCup is the graphical interface, the hierarchies of state machines, and the integration of internal and external Python code. The communication of the modules was done by ROS topics and messages, and this is also controlled by RoboCup. Additionally, the brain is in control of the Docker containers and the application inside the containers. Last but not least, the hardware team worked on a Bionic Gripper with slip and grasping detection. Together with Festo, we built a soft Bionic 2-finger gripper with force sensors on the inside. Thank you very much for your attention.